Today we're going to take a look at section 10.2, which is on simplifying radicals. And I think we've done a little bit of this before, but one big thing that's going to be really helpful for you today is to have your factor sheet handy. Okay? And also the next couple lessons as well. So if you need to take a minute, push pause, go print this off, or go find it, grab it. But it's going to be very useful these next couple of lessons here. Okay? But what we're going to look at is we're going to work on simplifying radicals. And like I said, I think we did a little bit this before. Well, let's suppose I started with the square root of 20. And these are all going to be square roots that we're going to try and simplify. And just like fractions, we always want fractions to be in lowest form or reduced form. The same thing is true with radicals. Now, you've done things with ones that are perfect squares, like the square root of 9 is 3. The square root of 25 is 5, and so on. Those ones that have nice square roots. But what about ones that are not perfect squares, like the square root of 20? Can that be reduced at all? And it sure can. And this is where we did our factor sheet. Okay, and 20 has several different factors, but we want to find the ones that are highlighted in black on the factor sheet here. And because that's the biggest one, that's a perfect square. So if you look at the square root of 20, or 20 on your factor sheet, you're going to see 4 and 5. And the reason those are in black, because 4 is a perfect square. Okay? And notice again how I exit off, circle it, and then look at this one, and that's as far as I can go there as well. So my answer is 2 square roots of 5. Okay? And again, if you can use the ones that are highlighted in black on your factor sheet, it'll save you the most amount of work, the fewest number of steps. Okay? Just make it a little bit easier. Okay? I need to see your factor trees in these today also on your homework assignment. So make sure you show your work. Okay? Let's take a look at a couple others here. How about the square root of 45? Now 45 is not a perfect square, but if you look at your factor sheet, you'll see the two that are highlighted in black are 9 and 5. And the nice one of those numbers is the square root of 9. The square root of 9 is 3, and again, that's the end of the road. I end up with 3 square roots of 5. Okay? How about a little bit bigger numbers? How about the square root of 108? Okay, 108 is not a perfect square. Okay? But if you look on your factor sheet, you'll see the two that are highlighted in black are 3 and 36. The square root of 36 is 6. And I end up with 6 square roots of 3. Okay, so they can be big numbers, they can be small numbers, doesn't matter. Okay? What if you came across a really big number that is not on your factor sheet? Okay, like 216. Okay? 216 is not a perfect square. Okay? So then what do you do? And it's not on your factor sheet either. Well, we want to find a pair of factors where at least one of them is a perfect square. Okay? And the numbers you want to try dividing by, maybe I'll make a little list here, are the perfect squares. Okay? So while 1 squared doesn't help me, but 2 squared is 4, 3 squared is 9, 4 squared is 16, 25, 36, and 49. We could keep going on and on. Okay, but really the main ones you really want to check would probably be like 4, 9, 25, 36, and 49. And I guess you could, well, any of them. But we just need to find one of those numbers that goes into 216. Okay, and sometimes it has more than one. Okay, but if I'm going to try the first one. If you tried 216 divided by 4, it would tell you 54. So that means 4 and 54 work. Now you could keep going and try and find the biggest one. Okay, but I did it this way. 4 I know is a perfect square. Its square root is 2. Now 54 is still not a perfect square. But the good news is 54 is on your factor sheet. If you look at 54, you would see that 9 times 6 are the two that are highlighted in black. And the square root of 9 is 3 again. And the square root of 6, that's a dead end. Okay, so it took us a couple steps on that one. But the thing here to make note of is, what do you do with these two big numbers, the ones that were perfect squares? Well, on the factor trees, everything is multiplication. So this is 2 times 3. It's going to be 6 with the square root of 6 left over. Okay, and you're going to see a couple problems today where the number's too big and it's not on your factor sheet. once again, just try and find one of these that goes into it. If you can find one of these that go into it, the other number may not be a perfect square, but this number will be on your factor sheet that you can break it down one more time. And just remember, all the big numbers that you have left that were perfect squares, they get multiplied together to get you that big number in front. Okay? So again, hopefully it's not too terribly bad. Okay? The next thing I want to talk about is, what about variables? Can variables be perfect squares? I think we've seen things like this. The square root of x squared is just x. Okay? The square root of x to the 4th is x squared. The square root of x to the 6th is x cubed. Okay, and there's some little patterns here. We're just dividing the exponent by 2. And they all divide unevenly. And any even exponent is going to divide evenly. Okay, but what about if I had x to the 5th power? Okay, Okay, well, if you think about this, x to the 5th is 5 x's. And every 2 make a perfect square, turn into a big X out in front. These 2 turn into a big X out in front, and that guy's all by himself underneath. Okay, and I end up with x squared, square roots of x. So you can kind of think about how many groups of 2 are there in 5. There's 2 groups of 2 in 5, with 1 left over. Another way to think about it is, what's 5 divided by 2? Or how many times does 2 go into 5? Well, 2 goes into 5 2 times. Okay, that's 4, with the remainder of 1. Okay, so there's 1 left over. But in order to get out from under the radical, it has to have a partner. There has to be at least 2 of them. Okay, I'm going to practice just a couple others here. How about this? How about the square root of x to the 7th? Okay, some people like writing them out. Okay, those 2 turn into a big one. Those 2 turn into a big one. And those 2 turn into a big one. So I have x cubed. There's 3 big ones. Oops, sorry, not 3. And then the little x, the little leftover, the remainder, is on the inside. Okay? Or you can think of it this way. 2 goes into 7 3 times. 2 times 3 is 6, with a remainder of 1. Okay, and with square roots, if it doesn't go in there evenly, you're always going to have a remainder of just 1. Okay? How about one more here? How about the square root of x to the 11th? Let's think about this. How many times does 2 go into 11? 2 goes into 11 5 times. 2 times 5 is 10, and there's 1 left over, the 11th one, that's underneath the radical. Okay, so we can do it with variables as well. Okay, let's try a couple of these ones. What if I had 32, the square root of 32x cubed, y to the 4th? Let's try that. Okay, and with these, with variables, let's do the big number part, the 32, and the variables separately. Okay, well 32, if you look at your factor sheet on 32, the 2 that are highlighted in black would be 16 and 2. The square root of 16 is 4. Okay, and that's the end of the road. So this turns into a 4 with the square root of 2 left over. And again, we can just do that part all by itself. Let's look at x to the 3rd. Okay, if you remember, that's 3 of them. Every 2, these 2 turn into a big X out in front, and then there's 1 left over underneath the radical. Okay, y to the 4th. You can think of it as 1, 2, 3, 4. These 2 turn into a big Y, those 2 turn into a big Y, and I end up with 2 of them, which is y to the 2nd. And it doesn't have any remainders. That one divided in evenly. So 4x, y squared, square roots of 2x. Okay, let's try one more of these. Okay, how about the square root of, let's try the square root of 125. A to the 6th, b squared, c. Oops. Let's do c to the 3rd. How about this? Okay, if I look at 125, 125 is on your factor sheet. The 2 that are in black are 5 and 25. The square root of 25 is 5. So I have a 5 and a square root of 5 left over. let's look at a's. And again, I'm doing a square root, so I'm dividing by 2. 6 divided by 2 divides in there evenly. It's 3 times. So I have an a to the third. 2 divided by 2 is 1. It goes in there evenly. It's b to the first. But 3 doesn't divide by 2 evenly. Okay? 2 goes into 3 one time, so I have a c to the first with 1 left over. Okay? And there would be my answer right there. Okay? So again, variables aren't anything to be scared about as well. We're just going to divide it by 2. Okay? If they don't divide it evenly, it's going to have 1 as a remainder left over. Okay? All right, let's put this all together here. Okay? What if I had something that looked like this? 2 square roots of 12, x to the 5th, y. Let's leave it like that. 2 square roots of 12, x to the 5th times y. Now, this time there's a number in front. What's that number doing out in front? Well, it's just a multiplier. Okay, really, we can just kind of ignore it for starters. Let's look at the 12. There's a couple different ways to factor 12, but again, the 2 on your factor sheet we're going to do are 4 and 2. I'm sorry, 4 times 3 is 12. So 4 and 3. The square root of 4 is 2. And I get a square root of 3. Okay, so again, I like doing all the number parts first, and I'm going to save the variables for last. But what a lot of people forget about is, what do I have to do with this one? I have to multiply it by this number out in front. It's a multiplier. Okay, so what I have is 2 times 2, I get 4, with the square root of 3 left over. Okay, don't forget to multiply it by the number in front. Okay, very good. Now let's look at Mr. X here. X to the 5th. I'm doing a square root. 2 goes into 5 2 times. So I'm going to have x squared. Okay? And that's 4. It gives me a remainder of 1, so there's 1 left over. Okay? And how about y to the first? Can you do 1 divided by 2? Or does 2 go into 1? Nope. It just stays y to the first. In the past, people talked about this way. In order to get out from under the radical, you have to have at least a 2. It has to be at least a square, so it cancels out with that one. If it's only a 1, then it just stays a 1 right underneath there. So there's my answer right there. I have a big number part out in front, and the variable part, and the radical part. Okay? Let's try 2 more here. How about this one? -5 square roots of 27, x cubed, y to the 4th, z to the 5th. Okay? How about something like that? Okay? So again, this -5 is just a multiplier. I'm going to just leave that alone for now. And I'm going to mess with the 27. And on your factor sheet, 9 times 3 is 27. Okay, 9 turns into a 3. And that 3 has to multiply that -5. So I get -15. And then the square root of 3 left over. Okay, so there's kind of the number pieces. Okay, I'm doing a square root, so how many times does 2 go into 3? Or what's 3 divided by 2? It goes in there 1 time with 1 left over. The y's, 4 divided by 2 is 2. That divides in evenly. It's a y squared out in front. And 5 divided by 2, well, 2 goes into 5 2 times. So I get a z squared, but there's 1 left over. And there's our answer right there. Okay? All right, one last one for the day. And we're going to call it good. Okay? Okay? Let's take a look at this guy right here in the middle. 88m cubed, p to the 2nd, r to the 5th. Okay, if you look at your factor sheet, 88's not a perfect square. Okay? And if you look at your factor sheet, the ones in black, there's 4 and 22. 4 and 22. The square root of 4 is 2. So right now I have a big 2. And 22, if you look on your sheet, it doesn't have any black ones. That's as far as it can go. It's as simplified as we can. Okay, so I have a 2 and a square root of 22. Now m to the 3rd. 3 divided by 2, or 2 goes into 3 1 time. Okay? So there's an m to the first with 1 m left over. 2 divided by 2, well, that's a perfect square. Oops. It's a perfect square. It goes in there 1 time. And then 5 divided by 2 goes in there 2 times. So r to the second with 1 left over. Okay? And this is what we're doing on your assignment today. We're just simplifying. Okay, we're taking the big number part, using our factor sheets to simplify the radical. And anytime we have variables, we're dividing them by 2. If they divide evenly, they go out front. If they don't divide it evenly, they're going to have a remainder of 1 underneath the radical. Okay? All right, thanks for tuning in.